Imagine living inside a metal tube, hundreds of meters beneath the ocean. No sunlight, no fresh air, no open windows, no immediate escape, just steel, machinery, and the crushing pressure of millions of tons of water above your head. Now imagine staying there for weeks, sometimes months, completely isolated from the outside world, and somehow continuing to operate one of the most sophisticated machines humanity has ever created. That machine is a submarine. From the outside, submarines appear surprisingly simple. A dark hull, a few antennas, a vessel that disappears beneath the waves. But beneath that surface lies an astonishing level of engineering complexity, because a submarine is not simply a ship that goes underwater. It is a self-contained ecosystem, a moving city, a survival machine, and perhaps one of the most difficult engineering challenges ever solved. The ocean is trying to destroy you. Most vehicles operate in environments humans naturally understand. Cars drive on roads, aircraft fly through air, ships float on water. Submarines are different. They enter an environment fundamentally hostile to human life. The deeper a submarine dives, the greater the pressure becomes. Every few meters downward, the ocean pushes harder against the hull. At extreme depths, the force becomes almost unimaginable. A small structural weakness can become catastrophic. A tiny crack can become fatal. A single engineering mistake can place dozens or even hundreds of lives at risk. That's why submarine hulls are built using some of the strongest materials ever used in transportation. Every weld, every joint, every structural component is carefully inspected, because unlike a surface vessel, a submarine cannot simply stop and wait for help. When something goes wrong underwater, the situation can become critical very quickly. And yet, despite this constant threat, modern submarines routinely descend into depths that would instantly crush most other vehicles. At certain depths, the pressure outside a submarine can be equivalent to having several jumbo jets pressing against every square meter of its hull. But surviving the pressure is only the beginning, because a submarine faces another challenge, one that sounds deceptively simple. How do you make a ship sink and then rise again whenever you want? The genius of ballast systems. The secret lies in ballast tanks. These large compartments allow submarines to control their buoyancy with extraordinary precision. When the tanks fill with water, the submarine becomes heavier and begins to descend. When compressed air pushes that water out, the vessel becomes lighter and rises toward the surface. The concept sounds simple, but the execution is remarkably complex. Submarine crews constantly manage balance, weight distribution, trim, depth control. Because underwater, even small changes matter. A poorly balanced submarine can become inefficient, difficult to control, or in extreme situations dangerous. Modern submarines rely on sophisticated sensors and control systems to maintain stability. Every movement is calculated, every adjustment carefully controlled. The result is something almost magical, a vessel weighing thousands of tons, floating silently in three-dimensional space beneath the ocean, neither sinking nor rising, simply suspended in darkness. A modern submarine can maintain a specific depth with astonishing precision while moving through one of the most unpredictable environments on Earth. The problem of breathing underwater. Now imagine another challenge. You're trapped underwater for months. No access to fresh air, no open atmosphere, no way to simply roll down a window. So how do submariners breathe? The answer is extraordinary. Submarines essentially manufacture their own atmosphere. Specialized systems remove carbon dioxide, generate oxygen, control humidity, filter contaminants, and maintain air quality around the clock. In many ways, the environmental systems inside a submarine resemble those used in spacecraft, because both face the same fundamental problem. Humans living inside a sealed machine. Every breath must be accounted for, every system must remain operational, and every failure could have serious consequences. The crew may never see these systems, but their survival depends on them every minute of every day. But breathing isn't enough, because a submarine must also solve another challenge, one that affects every human being on board: finding food, producing water, and sustaining life for months at a time. The hidden city inside the hull. Life aboard a submarine is unlike life almost anywhere else. Space is limited, privacy is rare, resources are carefully managed. Yet despite these constraints, everything needed for survival must exist inside the vessel. Food storage, sleeping quarters, medical facilities, communication systems, power generation, waste management, freshwater production. Even something as ordinary as drinking water becomes an engineering challenge. Many submarines produce fresh water directly from seawater using specialized purification systems. Every meal, every shower, every cup of coffee depends on machinery functioning correctly. The submarine becomes a miniature society isolated from the outside world. A floating, or rather submerged community, operating entirely within a steel shell. And the longer missions become, the more impressive this achievement appears. Because sustaining human life underwater is not simply transportation, it is environmental engineering on an extraordinary scale. Some submarines can remain underwater for months without needing to return to port. The silent war against noise, perhaps the most fascinating challenge in submarine engineering, is not movement, or pressure, or survival. It's silence. Underwater, sound travels extremely well, which means noise can reveal a submarine's location. Every vibration matters. Every mechanical sound matters. Every rotating component matters. Submarine engineers spend enormous effort reducing noise. Machinery is mounted on special systems. Propellers are carefully designed. Equipment is isolated from the hull. Even crew behavior may be adjusted during sensitive operations. The goal is simple: become as quiet as possible. Because in underwater operations, the submarine that hears first often gains the advantage. This obsession with silence has produced some of the quietest machines ever created. Machines designed not only to survive underwater, but to disappear within it. Modern submarines can be so quiet that detecting them becomes one of the most difficult challenges in naval engineering. Navigating in complete darkness. Imagine driving through a city with no windows, no GPS signal, no landmarks, no direct view of your surroundings. That is surprisingly similar to submarine navigation. Once submerged, visual information becomes extremely limited. The ocean is often dark, featureless, and vast. Submarines rely on sophisticated navigation systems, inertial guidance, sonar, advanced sensors, computer modeling, constant calculations. Crews must know where they are, even when they cannot see the outside world. The challenge becomes even greater during long deployments. Small navigation errors can accumulate over time, which means precision becomes essential. A submarine operating hundreds or thousands of kilometers from home cannot afford uncertainty. Every course correction matters, every calculation matters, and every decision influences the success of the mission. But even all of this complexity leads to one final question: why build submarines at all? Why invest so much effort into creating such difficult machines? Why submarines matter? The answer lies in something remarkably simple: access. Submarines can operate where few other vehicles can. They can travel vast distances, remain hidden, gather information, conduct research, support scientific exploration, and perform missions impossible for surface vessels. Military submarines often receive the most attention, but submarines also contribute to science, oceanography, environmental research, deep sea exploration, infrastructure inspection, and the study of some of Earth's least understood environments. Because despite centuries of exploration, much of the ocean remains mysterious, and submarines are among the few tools capable of helping us understand it. In many ways, they are not just engineering achievements, they are exploration machines. Machines that allow humans to enter a world we were never naturally designed to inhabit. At first glance, a submarine may seem like little more than a vessel that travels underwater, but beneath that simple idea lies one of the greatest engineering accomplishments in human history. A machine capable of resisting immense pressure, creating breathable air, producing fresh water, sustaining life, remaining silent, navigating in darkness, and operating for months in one of the harshest environments on Earth. Every system inside a submarine exists because survival depends on it. Every component serves a purpose. Every detail reflects decades of engineering innovation. Because building a submarine isn't simply about going underwater. It's about creating an entire world inside a machine. And perhaps that's what makes submarines so extraordinary. Not their size, not their power, not even their secrecy, but the fact that they allow humans to survive and thrive in a place where nature never intended us to be. Could you spend months living inside a submarine deep beneath the ocean? Let us know in the comments. But submarines aren't the only machines that push engineering to its limits. Because on land, some vehicles are so large they can move entire mountains. The massive machines used in open pit mining,